This is SpaceTime, Series 29, Episode 101, for broadcast on the 24th of August 2026. Coming up on SpaceTime, NASA forced to scrap its Swift rescue mission, the Milky Way's first big galactic collision, and understanding the stuff atoms are made of. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA has been forced to abandon its planned rescue mission to save the Swift Gamma-ray Space Telescope. Ongoing attitude control problems with the Link rescue craft mean the mission has been scrapped, and Swift will now be allowed to fall back to Earth in an uncontrolled descent in the next couple of months, burning up in the atmosphere. Swift was designed to provide astronomers with an early warning system for the detection of the most powerful explosions in the universe, gamma-ray bursts. These events only last a matter of seconds before quickly fading away, and Swift provided the necessary heads-up needed to allow astronomers to swing more powerful telescopes towards the direction of the blasts. Swift was launched in November 2004 on a 600-kilometre high orbit, which was thought to be high enough to allow it to remain operational for its primary 2-year mission, and so it wasn't equipped with any onboard propulsion systems. However, the mission has been so successful, detecting around 100 gamma-ray bursts every year, that managers just kept the mission going for 21 years. However, the current climax of the Sun's 11-year solar cycle has been more violent than anticipated, sending powerful solar flares and coronal mass ejections towards the Earth and causing the planet's atmosphere to wobble, expanding and contracting with each new space weather event. And that's led to increased atmospheric drag on the spacecraft, accelerating its orbital decay. The Link rescue craft was meant to rendezvous with Swift, then maneuver around the orbital telescope, find a good attachment point, and then use its 3 robotic arms to capture and gradually boost Swift back up into a higher orbit. The Link spacecraft was flown into orbit on July the 3rd aboard a Northrop Grumman Pegasus XL rocket, which was drop-launched from the underbelly of a specially modified Lockheed L-1011 TriStar airliner 40,000 feet above the South Pacific Ocean. Mission managers established communications with Link and conducted in-orbit checkouts over the following weeks. However, the Link spacecraft suddenly experienced a major anomaly, sending the vehicle into an uncontrolled multi-axis spin, tumbling wildly in orbit and sporadically losing communications with mission managers on the ground. While the rescue vehicle's operators, Catalyst Space, were able to get some control over the spacecraft, it wasn't enough to save the mission, and so NASA have taken the decision not to proceed with a rescue attempt. This is SpaceTime. Still to come, the Milky Way's first big galactic collision, and understanding the stuff that atoms are made of. All that and more still to come on SpaceTime. Astronomers have discovered what was probably the first major galactic collision involving our home galaxy, the Milky Way, cannibalising a dwarf galaxy called the Low-Energy Kraken Heracles, or LKH, less than 2 billion years after the Big Bang. The Milky Way grew to its current size by consuming, merging with, or cannibalising smaller galaxies. In fact, that's how all galaxies grow. Now, new data from NASA's Hubble Space Telescope has shown definitive evidence of a dwarf galaxy merging with the young Milky Way in the earliest phases of its evolution. The findings, reported in the journal Nature Astronomy, extend science's understanding of our galaxy's history by some 1.8 billion years. The most recent massive merger in our galaxy's history took place with the Sagittarius dwarf galaxy, beginning more than 6 billion years ago and still happening today. Looking back into the even more distant past, astronomers learned that the Milky Way consumed another dwarf galaxy called the Gaia Sausage Enceladus about 10 billion years ago. This ancient merger greatly affected the structure of our galaxy's disk of stars. Lots of other smaller mergers have occurred between these two major events. But of course our galaxy's history doesn't stop there. Both observations and computer simulations have suggested another, much larger merger preceded these two, though the exact specifics of this event have been heavily debated. Now, Hubble's uncovered definitive evidence of the earlier merger, which occurred around 11.8 billion years ago. That's just 2 billion years after the Big Bang. The study's lead author, David Mazzari from the Astrophysics and Space Science Observatory in Bologna, says while the Milky Way is our home galaxy, we don't fully understand how our house was built. Using NASA's Hubble Space Telescope, together with astronomical surveys and data from other spacecraft like the European Space Agency's Gaia mission, Mazzari and colleagues have been piecing together the early history of our galaxy. Of course, the further back in our galaxy's history scientists attempt to look, the more difficult it becomes to fully understand what's going on. When the Milky Way was young, it was much smaller and much closer in size to the galaxies it was crashing into. It was also more chaotic, and it's possible that signs of mergers have been erased over billions of years. And it was into this murky past that Hubble has been peering. The authors used Hubble to study the Milky Way's globular clusters, immense, roughly spherical collections of tens of thousands to millions of stars. Globular clusters contain some of the oldest stars in our galaxy, and they can act as cosmic archaeological sites, preserving stars from other galaxies the Milky Way's collected. Thanks to the high resolution and deep Hubble imaging, the authors were able to measure both the age and metallicity of these clusters with unprecedented precision. Astronomers refer to all elements on the periodic table other than hydrogen and helium, which were formed in the Big Bang, as metals. And metals are created in stars, either during their lifetime or when they die. And so the greater the metallicity of a star, the older it is. Thanks to the high resolution and deep Hubble imaging, coupled with the measurements from Gaia, this made it possible to distinguish a population of globular clusters that appear to be very different from the others. And these are the clusters that were born in the ancient dwarf galaxy LKH, and they tell both how big this galaxy was and when it was cannibalized by the Milky Way. The authors analysed Hubble observations of 39 globular clusters from the inner 20,000 light-years of our galaxy, where evidence of the most ancient mergers should be preserved. They expected this sample to contain globular clusters that formed within the young Milky Way, as well as those collected from the Gaia Sausage Enceladus dwarf galaxy about 10 billion years ago. Using Hubble's sensitive observations to determine each cluster's precise age and associated metallicity, Mazzari and colleagues determined there was a third population of globular clusters within the inner regions of our galaxy. They found these clusters are older than the group collected in the Gaia Sausage Enceladus merger, but younger than those born in the original Milky Way, regardless of their metallicity. These clusters, therefore, came from a separate, even earlier merger, in which our Milky Way absorbed, cannibalized if you will, a dwarf galaxy containing roughly 500 million times the mass of our Sun, a significant fraction of our galaxy's total mass at the time. They named this dwarf galaxy Low Energy Kraken Heracles, or LKH, in honor of 3 earlier research papers that championed the idea of a merger early in our galaxy's history. Now, when you think about it, such a large merger so early in the Milky Way's formation history would have had profound implications for the evolution of our galaxy. Mazzari says that some past studies have argued that this earliest phase of our galaxy's evolution was defined by stars born only in our own galaxy. But he says this shows that stars born in external galaxies also need to be considered. This is space-time. Still to come, understanding the stuff atoms are made of. Later in the science report, successful Phase 3 trials of a new Australian-developed personalised mRNA cancer vaccine. All that and more still to come on Space Time. New observations made at the Large Hadron Collider, the world's biggest atom smasher, are revealing some of the basic fundamental physics of our universe. The new measurements are challenging long-standing hypotheses of how gluons behave inside atomic nuclei. Gluons are force particles that bind subatomic elemental particles called quarks together inside protons and neutrons, making up the nucleus of atoms. Now, new research by the ALICE experiment at CERN's Large Hadron Collider is showing how 2 rival explanations for how gluons behave inside atomic nuclei can now be experimentally distinguished. The researcher reported in the journal Physical Review Letters provides the first multidimensional measurements of incoherent J-psi photonuclear production as a function of both interaction energy and momentum transfer. This measurement gives scientists their clearest view yet of how gluons act at high energies. One of the study's authors, Daniel Tapiotakaki, from the ALICE collaboration at CERN, the European Organisation for Nuclear Research, says that although quarks are often described as the fundamental building blocks of matter, nearly all the mass of the visible universe, from the atoms in your body to the matter inside stars, actually comes from the energy carried by gluons, the strong nuclear force that binds quarks together. Understanding how gluons behave inside nuclei is therefore essential to understanding how matter itself acquires its mass and structure. To study how gluons fluctuate within nuclei with more spatial resolution than ever previously possible, the authors used an experimental technique called incoherent J-psi photonuclear production. Tapiotakaki says the measurements were performed using data collected during run 2 of the Large Hadron Collider, where fast-moving lead nuclei pass close to one another without directly colliding. In these encounters, intense electromagnetic fields surrounding the nuclei behaved as beams of high-energy photons. When one of these photons strikes another nucleus, it can briefly produce a particle called a J-psi, whose production provides a sensitive probe for the underlying gluon structure. Unlike other measurements that average over the entire nucleus, incoherent J-psi production is sensitive to local fluctuations in gluon density, allowing scientists to probe structures smaller than a proton. And these intense gluon fields, present inside every nucleus, make up nearly all of the visible matter in the universe. Yet their collective behaviour remains one of the greatest challenges in modern physics. Tapiotakaki says these experiments using incoherent production is sort of like switching from a blurry image to a high-resolution microscope. It allows scientists to see how gluons fluctuate and organise themselves inside atomic nuclei. By varying the momentum transfer, the experiment effectively changes the focus of the microscope. At resolutions of 0.6, 0.3 and 0.2 femtometers, ALICE progressively probes smaller and smaller regions inside the nucleus. The finest resolution corresponds to structures only a quarter the size of a proton. At these extraordinary scales, physicists have observed evidence that the gluons begin to behave collectively, a phenomenon known as gluon saturation. The authors measured incoherent J-psi production across a wide range of photon nucleus energies, from 20 right up to 633 billion electron volts. At the same time, they also examined how the interaction changes with momentum transfer, which corresponds to how finely the nucleus is being probed. The results revealed a striking pattern. At the smaller spatial scales explored, the production rate of J-psi particles was significantly suppressed, with a statistical significance of about 3 standard deviations. This suppression challenges a long-standing explanation known as nuclear shadowing, which has successfully described previous measurements. Now, in that framework, gluons inside the nucleus partially overlap and obscure each other, similar to layers of clouds blocking out sunlight, reducing the probability of certain particle production processes. The new measurements indicate that conventional nuclear shadowing alone can't fully explain the observed data. Instead, the observations are consistent with a different phenomenon known as gluon saturation, which is predicted by the theory of quantum chromodynamics, which describes the strong nuclear force. Tapiotakaki says that in this regime, gluons become so densely packed that they begin interacting strongly with one another, limiting how many can exist in a given region. The project is just one of hundreds of experiments being undertaken by CERN, the European Centre for Nuclear Research.
CERN is the world's largest particle physics research laboratory. It covers 6 square kilometres, scattered over 12 sites either side of the Franco-Swiss border near Geneva. In 34 kilometres of tunnels and caverns the size of cathedrals, at over 100 metres underground, CERN hosts facilities for experimental physics. Scientists from all over the world work here in international collaborations to study and understand the mysteries of the universe. Stars, planets, seas, air, humans, everything around us is made of matter. Matter is made of atoms. Atoms are made of electrons orbiting around a nucleus, which in turn is made of protons and neutrons. Inside these, we find quarks. In CERN's newest accelerator, the Large Hadron Collider, particles collide at nearly the speed of light to study the quarks and other particles. Many of these particles only existed in the early universe for a fraction of a second after the Big Bang, when all the energy transformed into matter. In CERN's accelerators, we can recreate conditions that existed just after the Big Bang and shed light on such questions as, why do particles have mass? What is the nature of dark matter in the universe? Why did matter triumph over antimatter in the first moments of the universe, making our existence possible? What was the state of matter just after the Big Bang? 4 gigantic instruments called particle detectors study the data from the LHC collisions in search of the answers to these fundamental questions. The experimental and theoretical study of these conditions allows us to understand the fundamental laws of nature and to unveil the ultimate mysteries that govern our universe. In the course of their research, CERN scientists have often come across discoveries that have affected our everyday life. The technology used for particle detectors is at the origin of security scanning equipment and several medical applications. And the World Wide Web was invented at CERN in 1990 by the British scientist Tim Berners-Lee. The web soon grew beyond the world of particle physics and has become our primary repository of information, changing and improving the way people interact and communicate. To treat these massive amounts of data produced by the Large Hadron Collider, physicists, together with experts from industry, are building a web of cooperative computing called the Grid. The Grid will allow thousands of research centers and universities to share their data storage resources and computing power, transforming the internet into a giant global supercomputer and building capacity for the science of tomorrow.
This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. Australia's recorded its first case of H5N1 bird flu in a mammal on the mainland. Authorities say the virus was found in a dead long-nosed fur seal at Beachport on the South Australian Limestone Coast 300 kilometres south of Adelaide. The infection likely came from contact with nearby sick seabirds. The Australian mainland had been bird flu free until the current outbreak began in June. There have now been over 300 positive H5N1 bird flu events recorded in Australia since the outbreak began, with 194 of those in South Australia alone. Federal Agriculture Minister Julie Collins says the concerning development wasn't unexpected. The virus's jump from birds into mammals was always coming, with 13,359 fur-sealed pups dying on the Australian territory of Heard Island a year ago, wiping out 75% of the local seal juvenile population. Researchers have found that wildfires, especially those that happen in areas that are used for mining, agriculture and where people live, could increase the levels of arsenic in nearby drinking water. A report in the journal PNAS reviewed 20 studies on fires across the world, including Australia, finding 16 showing an increase or likely increase in arsenic in bodies of water following a bushfire. They say runoff was the most common pathway for the arsenic, and while most average values didn't exceed drinking water standards, they found 6 of the studies showed that it did. They found the highest concentrations, 7 times the recommended maximum, was measured in water after a fire near an old mining operation, and higher values were seen downstream of burned agricultural and urban areas. Moderna and Merck have announced successful Phase 3 trials of a new Australian-developed personalised mRNA melanoma cancer vaccine. The successful trials mean the treatment could be made available to oncology patients within 2 years. The mRNA vaccine works by being tailor-made to each individual using the genetic blueprint of their individual tumour cells in order to help immune cells better recognise and eradicate those cancer cells. The company says their trial shows statistically significant and clinically meaningful improvements in the amount of time patients went without cancer signs or symptoms returning or spreading. The Phase 3 trials involved 1,137 patients split between the personalised mRNA vaccine combined with the current standard immunotherapy drugs and a control group that used just the standard immunotherapy drugs on their own. A new study warns that the more plastic pollution Sable shearwaters on Lord Howe Island consume as young seabirds, the less likely they are to survive at sea and safely return to their colony as breeding adults. The findings, reported in the journal PNAS, examined 15 years of data looking at how plastic ingestion by marine wildlife affects organisms at a population level. The birds belong to Lord Howe Island's Ned's Beach rookery in the South Pacific Ocean, 600 kilometres east of Taree on the New South Wales mid-north coast. The authors found that up to 20% of fledglings had ingested more than a gram of plastic, and consuming that much plastic was associated with at least an 11% reduction in the probability of birds surviving to return and breed at the colony. And birds that ingested more than 5 grams of plastic were almost always never seen again. A new study has shown that more than 90% of rainforests in the Blue Mountains west of Sydney may be hiding in plain sight, wrongly catalogued as eucalypt forests. A report in the Journal of Vegetation Classification and Survey claims scientists have uncovered previously unrecognised fire-sensitive rainforest communities tucked away deep in the region's rugged gullies, with rainforest extent found to be 3 to 4 times greater than what official maps indicate. The newly identified rainforests support ancient Gondwanian plant lineages, rare species, and previously unknown populations of critically endangered scrub turpentine. A rainforest is a tall, dense forest that gets very high amounts of rain each year, usually more than 1,800 to 2,500 millimetres. That's 70 to 100 inches on the old scale. These lush ecosystems cover only a small part of the Earth's surface, but are home to more than half of the world's plant and animal species. Ghostbusters claim they've uncovered a ghost haunting a long-abandoned pub in merry old England. The old Crying Tree pub at Gateacre near Liverpool is by no means the first English drinking establishment to claim it's haunted, and it almost certainly won't be the last. Originally built as a Victorian manor house in the 1880s, the listed building on Grange Lane was formerly known as the Crying Tree Bar and Grill. It's recently changed owners after being vacant since 2014, with plans to turn it into a children's daycare nursery now approved by the local council. But the Skeptics' Tim Mendham says ghost hunters claim it's a paranormal hotspot, and they've even photographed an apparition at the top of the stairs.
It seems to be the de rigueur of pub landlords that they have to be haunted to add some character.
They're full of spirits.
Yeah. The latest story was about a famous creepy house that supposedly had ghosts in it, and the reports are by independent people who happen to be paranormal researchers and ghost hunters who tend to go into these things believing in ghosts and the paranormal, even though they say they're yet to be convinced. It doesn't take a lot of event or episodes or evidence to convince them that these things are real. This is a house in a place called Gateacre. It's a pub, and they say, yes, it's definitely haunted because I've seen things there. This person says, you don't find many apparitions in our field, and this was an apparition at the top of a stairwell or something like that. It looks like a stain on the wall, but they say it wasn't a stain on the wall. It's just a dark shape, indeterminate shape. They say you don't find many apparitions in our field. They are very rare, and I've got about 3, and I've been doing it for 2 years, so a highly experienced ghost hunter. The weird thing is they haven't got a clue as to why this one particularly appeared in this place called the Crying Tree pub. They said, I've caught one in the graveyard before. I've caught one at another place where I don't remember the second place. You think if you only seen 3 in your life that you would have remembered where they were. But never mind. These stories are sort of a bit...
abiding by the spirits.
Yes, quite likely. But finding ghosts in pubs, virtually every pub in the UK has its resident ghost which knocks over pint glasses and this sort of stuff, or moves furniture, and this one was just a shape or something moving. They'll move very quickly, evidence is not very good, fuzzy photos, sometimes you see a ghostly shape and half the time they're fake. So another UK pub report of an indeterminate vague ghost produced by someone who's a believer in ghosts and is willing to see anything and doesn't remember where they actually saw ghosts in the past. Sad to say, I'm probably more cynical than sceptical of that one. Not very convinced.
That's the Skeptics' Tim Mendham, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.